Okay, this looks much neater than what I drew, but it's exactly the same thing. So let's compare those two. Okay, take a look. What's the difference? This is just a little neater than mine, right? So exactly the same thing. From Colorado, you have two edges. If you think about this as like rubber band or things like that, you can change this exactly same as this shape, right? Just switch it a little bit. Okay, so exactly the same thing. All right. Who's yawning? This is so fun thing. How can you be bored? Okay, you can also represent a floor plan to a graph. Okay, so this is a gym, one gym. This gym's floor plan is like this: Ray's training room, locker room, Sierra's training room, and in the middle there's a health slash weight room, Keegan's training room, locker room B, Chad's training room. So you have how many rooms? 1, 2, 3, 4, 5, 6, 7. So those become your vertices. And think about how you get there, like the bridge. So the opening here, the doors, become your edges. Can you construct a graph? Again, each of these 7 rooms become your vertices. The doors, how we get there, is you connecting one room to the other room, right? So that becomes the edges. So construct a graph using this floor plan. Dean, you got that? Dean, you got it? River, you got it?
I'm still working.
Again, each room becomes a vertex, and the doors that connect the rooms becomes the edges that connect the vertices, right? Cora, you got it? Oh, we need to actually add outside too, don't we? Because there's exit there, another door. So put 8 vertices, including outside. Let's try it together. Okay, so let's see. We have outside. We have race room. We have locker room A. Locker room A. These are the vertices, okay? And we have Sierra's training room. And we have Keegan's. Oh, we have a help. Wait. And we have Keegan's room. We have locker room B. And we have Chip's training room. So we have 8 vertices, right? Let's see. From outside, how can we connect this outside? Outside is connected to which room? You can go outside through which room? Locker room A. So it is connected in here. So Outside and locker room A is connected. Anything else with outside? How can you get out? Only this room? Also this room too, right? So here's another way. You see that? So I can connect this with hot weight room. Is that only way? Two ways only? Or more? On the other side too, it's open here. So you can go the other way around too. So you can connect this with this one as well. So are we done with outside? Is there any other way to go outside? I think that's all. So let's take a look at race training room. Race training room is connected to which rooms? Locker room A and the health. So locker room A and the health. Right? So we are done with the race. So I'm gonna circle when I'm done. So I don't get confused. Okay, now let's look at locker room A. Locker room A is connected with the outside. We are done. Race room, we are done. What else? Sierra's training room, right? So we're gonna connect that to Sierra's room. So we are done with locker room A. How about Sierra's room? It's connected to locker room A. We got that already here. And it's also connected to health. So we can connect that. So Sierra's room is done. Because there are only two doors, right? Let's look at health. We already have Rays and Sierras, and we have outside, and we also have Keegan's and Chit's room. So Keegan's and Chit's, we're done, right? How about Keegan's room? Keegan's room, you have two doors. To health, we already got that connected, and locker room B, you can connect them, right? From locker room B, you have only two ways. To Keegan's, it's already connected, and you can also go to Chit's training room, so connect that. And when you're looking at Chit's, room, we have only two doors, and we got two doors already connected. So something like this will be your graph. You got the similar one? Nice. Okay. Neater version is this. Okay, that's the neater version, but it's exactly the same as this one. Okay, because you can see the triangle here, and you can see, 446 here, 1, 2, 3, 4, and you have the loop around it, right? Any question? So representing two graphs is not too bad. We're going to talk about the degree. Degrees is important, okay? The degree of a vertex is number of edges that are connected to that vertex. So for example, what's the degree for this vertex? How many edges are connected to this vertex? This one, so degree 1. How about this vertex? What's the degree for this vertex? How many edges are connected to this vertex? 4. 1, 2, 3, 4. So this is degree 4. How about this one? This one. Degree 2. 1, 2. How about this one? 2. 1, 2. How about this one? 1, 2, 3. And some are even, some are odd. That's also important, okay? So we have the degrees for the vertices. 1, 2, 4, 2, 3. You can find it easily. Even vertex. Even vertex means when you have even degrees. So this one, and that one. These are the even vertex. The other two are odd vertex because they have odd degrees. Nothing hard, right? Okay, so here, can I skip all of that in the video sharing? Nobody said anything? Okay, last page is this that we're gonna do today. So here are some vocabulary you have to understand. Pad, circuit, bridge are different things. I said that at the beginning, right? Pad is a connected sequence of edges, starting at one vertex and ending at another. Well, it can be the same too. But if it's the same, so starting point, starting vertex and the ending vertex is the same, then what happens? It becomes, you come back yourself, it becomes a circuit. Okay? But if you go somewhere else, it's a path. So path includes circuit. Not all path is a circuit, but all circuit is a path. Okay? Bridge. Bridge is an edge of a connected graph. A bridge. If its removal causes the graph to be disconnected. We're gonna talk about this again when you return after the test on Monday, because it's gonna be some time I need to forget. And graph can be connected or disconnected. Okay? So we will talk about this again when we return. Again, Wednesday and Friday we're gonna meet in the computer lab. Wednesday we're gonna